In this video, I'll be going through 1.5, which is geometric sequences. So we finished arithmetic sequences in series, so we're on to geometric. And the only difference between arithmetic and geometric is that geometric, instead of adding the same common difference every single time, will be multiplying a same common ratio. So if we look at this geometric series over here, from 3 to 6, instead of adding 3, we're going to actually multiply 2. And then from 6 to 12 is also going to be multiplied 2. From 12 to 18, it's multiplied 2. And it keeps going. And this is what we call the common ratio R. Common ratio. And we use R to denote the common ratio. So let's have a look at another example geometric sequence. Maybe I can start with the number 8. And then the next term, if I multiply 1.5, it doesn't have to be a whole number. It can be a decimal. It can be a fraction. Let's say the next term, if I multiply 1.5, then this is going to be 12. And then if I multiply 1.5 again, that's going to be 18. And if I multiply 1.5 again, we'll get 27, and so on. So every single term here is times 1.5 times 1.5. That's a geometric sequence. Let's give an example of a geometric sequence where the common ratio is a fraction. Let's start with a slightly bigger number this time. If we had 24, and this time, the next term, let's multiply by 3/4. The next term is going to be 18. Okay, so if we multiply by 3/4, this is going to be 18. And if we do the same, if we multiply by 3/4 again, the next term is actually going to be 13.5, and so on. Okay, and if we continue to multiply by 3/4, we can have fractions. Maybe we can write this as 13.5 in decimal form, actually. 13.5 is going to be 13.5, or in improper fraction, 27/2. So this, we can write it as 27/2. And if we continue to multiply by 3/4, we would get 81/8, and so on. Okay, so this is a geometric sequence where every single term successive is going to be multiplying a same common ratio. Okay, so how do we know the common ratio if we're not given one? So let me just quickly show you an example. Let's start with 2 over here, and the next term is 6. The next term is 18, and the next term is 54. And so I'm not going to give you the common ratio, but you can determine what the common ratio is by dividing by its previous term. So if I take this term 6 over here and I divide it by 2, okay, so this is T2 divided by T1, okay, T2 divided by T1, I'm going to get 3. That's my common ratio. Now we can check it. Let's do T3 divided by T2 because it should be the same common ratio. If I divide T3 divided by T2, I should get the same number. 18 divided by 6 will also give me 3. 54 divided by 18 also gives me 3. Okay, so this is our common ratio R. Let's have a look at our first example over here. Before we move on to the example, let me just show us the general term, because we do want to find, what is the term number, how many terms, and so on. The term number for a geometric sequence, T of n, is going to be the first term multiplied by a common ratio to the power of n minus 1. Okay, so that's going to be the general term for a geometric sequence. Okay, let's move on to a class example. For the following sequences, identify the type of sequence, whether it is arithmetic or geometric. So state the common difference or common ratio depending on the sequence, and state the next two terms, okay, the fifth and the sixth term. So let's have a look at this. From 8 to 24, it's multiply 3. 24 to 72, also multiply 3. So I can say that this multiply 3, also multiply 3. It is going to be a geometric sequence. Geometric, and a common ratio R is going to be 3. Let's have a look at the next one. 108 to 72. If this is going to be a geometric, all I have to do is divide, right? 72 divided by 108. will give me 2/3 or 0.66. But let's have a look at 36 to 72. 36 divided by 72 is half instead of 2/3. So this is not going to be the same common ratio. So instead, I'm going to look at subtract, okay? 108 to 72, so 72 minus 108 will give me minus 36. And then 72 to 36 is also minus 36. And then 36 to 0 is also minus 36. So I know that this is an arithmetic sequence. Arithmetic. And the common difference, D, is going to be minus 36. Let's have a look at the next one. From negative 3 to 2, if I'm looking for a common ratio, all I have to do is T2 divided by T1. Okay, so common ratio is 2 over 3. And let's have a look at the next one. If I do 4/3, negative 4/3, negative 4 over 3, and I want to divide that by 2, I would get negative 2/3 as well. So I can see over here, this is going to be times negative 2 over 3. And from here to here is also times negative 2 over 3. And from here to here is negative times negative 2 over 3. And the thing with geometric sequences is if your common ratio is negative, every other term is going to be negative. Okay, it's going to alternate between positive, negative, positive, negative, positive, negative. Okay, so because every time we multiply by a negative number, if it's positive, it becomes negative. If it's negative, it becomes positive again. So that's why it alternates between positive and negative. Okay, so this is a geometric, and the common ratio R is negative 2 over 3. Let's have a look at the next example. It says determine the formula of the general term and calculate the indicated term of each of the following. Oh, I forgot to do the next two terms. Let's just do the next term for this. If we multiply 216 by 3, 216 times 3, the next term will give us 648. And then the next one is going to be 1944. I just realized I forgot to do the last part. Next one, if we subtract 36, it'll be negative 36. And then if we subtract another 36, it'll be negative 72. This one, if we multiply by negative 2 over 3, so let's start with 8 over 9. And we want to multiply this by negative 2 over 3. Then we would get a fraction of negative 16 over 27. And then the next one, if we multiply by negative 2 over 3 again, we would get 32 over 81. Okay, now let's move on to the next question. Determine the following formula and find the ninth term for this one. Okay, so here, the first thing we need to do when we want to work out what the general term is, let me just quickly write down Tn. Tn is equal to a times r to the power n minus 1. So we need the first term, we need the common ratio, and we need the number of terms. Here we already have the first term, that's a, that's 5. To work out the common ratio, r, you just got to think to yourself, 5 times 1 is 15, 15 times 1 is 45, that's 3. So I know the common ratio. Now let's put in T9 into our formula. T9 is going to be 5 times 3 to the power of 9 minus 1. And then let's just go ahead and calculate it. So 3 to the power of 8 times that by 5 will give us 32,805. Okay, now next one, we have 1/3, negative 1 over 6, and then positive 1 over 12. So the common ratio is going to be negative, and it's going to be negative half, because every single time we're going to be half, 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 half more. Okay, so it's negative half. Then we can work out what T7 is. T7 is the first term, 1 over 3, times the common ratio, that's negative half, to the power of 7. Okay, so make sure when you put this into your calculator, you do need to put the negative symbol inside the bracket so that you don't make a mistake, okay? Or else if you leave it outside, if we happen to have a even power, the even power is supposed to make the negative become positive. But if you leave it outside the bracket, it's going to stay negative. Okay, so you have to keep that in mind. So we have 1 over 3. Multiply that by bracket negative 1 over 2, all to the power 7. And you would get negative 1 over 384. Okay, moving on to the next example. So in this one, we have the final term, but we don't know what term number it is. Okay, and so in this example, Janice and Gary are trying to determine the number of terms. And so Janice used a guess and check method, and I'll just stick to this. Okay, I'm not going to go through the other method. If you're interested, you can probably find out yourself, or you can ask me directly. So we have 32 to 64. The common ratio R is equal to 2. Okay, so every single time we multiply 2, so the general formula T of n is going to be 32 times 2 to the power of n minus 1. Okay, so right now this is 32 times 2 to the power minus n minus 1. And then we don't know the number of terms, but I know that this is the last term. This is going to be my Tn, and I'm going to solve for n. So let's substitute that into Tn. So I have 16,384 is equal to 32 times 2 to the power of n minus 1. And what I'm going to do in my calculator is I'm actually going to do a guess and check. Okay, I'm going to put 32 times 2 to the power, and in my bracket I'm just going to do a random guess. It's a very big number, so I'm going to guess maybe 10 minus 1. And oh, on my first guess, I already got the answer. Okay, so 32 times 2 to the power of 10 minus 1 is 16,384. That was a lucky guess. Not every time that we're lucky, but this time we are kind of lucky. We got the answer straight away. So n is going to be 10. Okay, and it doesn't actually take that many tries to get the answer. If you have a good starting point and then you just make some adjustments just to guess a few numbers. Okay, and I've already done that. Okay, so this is the guess and check. I should actually put this into the other side as well. Okay, this should actually go over here. Okay, determine the solution by this method. Okay, so let's move on to another example. Now this one is the geometric means. Now for the geometric means, insert 4 geometric means between 81 and 1 over 729 means that there are going to be 4 numbers in between. So we're going to have 81 over here. I don't know which term number it is. It doesn't have to be the first term, but there's 1 term here, 2 terms here, 3 terms here, and 4 terms here. And then the 5th term after 81 is going to be 1 over 729. And so by geometric sequence, it means that every single time I'm going to multiply the same ratio r, and I'm going to multiply the same ratio r, I'm going to multiply the same ratio r, and multiply the same ratio r, and multiply the same ratio r again. So from 81 to 1 over 729, even though the question says 4 geometric means, we're actually multiplying r 5 times. Okay, so it's r to the power 5. Okay, we're multiplying r, all of that 5 times. So 81 multiplied by r to the power 5 will give me 1 over 729. And so to find r, I'm going to divide 81 to the other side. So r to the power 5 is equal to 1 over, and then 729 times 81 would give me 66,339. And all we have to do now is we're going to fifth root it. Okay, so we're going to fifth root r to the power 5, and we're going to fifth root 1 over 66,339, and fifth root of 66339, and we get it's not a nice number. 729. Let me just make sure I multiply this correct. 729 times 81. Oh, I wrote down the wrong number. Sorry. This number over here, it's supposed to be 59,049. Let me go ahead and change this. 59049. Now it should work. Okay, sorry. 5 root of 59049, and we'll get the nice fraction of 1 over 9. Okay, so this is going to be the common ratio. And so if I know that r is 1 over 9, all I have to do is just keep multiplying. 81 times 1 over 9, and I would get 9. And then this will be 1, and this will be 1 over 9, and this will be 1 over 81, and then the next one will be 1 over 729. Okay. Yeah. Okay. Moving on to the next question. I know this video is getting a little bit long. Just bear with me. Three consecutive terms. We have x plus 3, x, and x minus 5. Okay, these are three terms. The first three terms in a geometric sequence. And so, in order to do this, we know that there is a common ratio r times r and times r. We don't need to know what that r is, but we can say that this term t3 divided by t2 and t2 divided by t1 should be equal because it's a common ratio. Okay, so here what we need to do is we need to set up an equation. T3 divided by t2 is equal to t2 divided by t1, and then we just solve it by equations. So let's go ahead and do that. X minus 5 over x is equal to x over x plus 3. Let's cross multiply, so we have x minus 5 times x plus 3 equals to x squared. We have x squared minus 5x plus 3x, so that's minus 2x, and this is minus 15 is equal to x squared. This x squared and this x squared cancels out with each other, and so we have negative 2x equals to 15. So x is equal to negative 15 over 2, or you can say that this is negative 7.5. Okay, so we found out the value of x, and then now we have to find out what the three terms are. Okay, so let's put this back into our free terms. So 7.5 plus 3, that's going to be negative 7.5. That's going to be, first three terms is negative, negative 7.5 plus 3, if you're not sure, negative 4.5, negative 4.5, and then the next one is just x itself, so that's negative 7.5, and then the next one is x minus 5, so negative 7.5 minus 5 is negative 12.5. Okay, how do we confirm that if this is a geometric sequence? Just divide. Okay, so if I do 7.5 divided by 4.5, it's 1.666. 12.5 divided by 7.5 is also 1.66666. Okay, so this is a geometric sequence. Now this is the very last example, and I'm running very long. It says the fourth term and the seventh term of a geometric sequence are negative 54 and 1458. So I know that this is T4 is negative 54, and somewhere along the line this is T5, this is T6, this is T7, and this is T8. This one is going to be, the fourth term and the seventh term. So I went one too many. Seventh term are 1458. Okay, so we have the fourth term and the seventh term, and so use system of equations to determine the values of the first term and the common ratio. We don't have to use system of equations. It's not the only way to do this, and so sometimes an easier way is just to use the Tn formula. Remember, Tn formula is equal to a times r to the power of n minus 1, and so what I can do is I can determine what the common ratio is, because this is times r, this is times r, and this is times r 3 times. Okay, so once, twice, 3, so negative 54 times r to the power 3 will give me 1458, and all we have to do is solve this equation. R cubed, 1458 divided by negative 54 will give us negative 27, and so r is going to be negative 3. That's my common ratio. So now I know r, I can just put in T4 into my Tn formula. So T4, which is negative 54, is equal to a, which I don't know, times the common ratio, which is negative 3, to the power of 4 minus 1. And so with this, I can work out what a is. So negative 3 negative 3 times to the power of 4 minus 1, which is to the power 3. Negative 3 to the power 3 will give me negative 27. And so a is equal to negative 54 divided by negative 27. And that will give us a value of 2. And now that I know that a is 2, I can find the general term of the sequence. Okay, Tn is equal to 2 times r, which is negative 3 to the power of n minus 1. Okay, so this is going to be the general term of the sequence, and this is our first term. Okay, so we've done the value of the first term. We found the common ratio over here, and we found the general term, which is down there. Okay, so that is it for this video. Thank you for watching.